Alrighty. Time for some late night coding. Words within 2 edits of dictionary. Medium. You're given 2 arrays, string arrays, queries, and dictionary. All words in each array comprise of lowercase English letters and have the same length. Okay. In one edit, you can take a word from queries and change any letter in it to make to any other letter. Find all words in queries that after a maximum of 2 edits equal some word from the dictionary. Return a list of all words in queries that match the same word from the dictionary after a maximum of 2 edits. Return the words in the same order that appears in queries. Okay. Maximum of 2 edits. Word. I guess you can't make it into wood because you have to change a maximum of 2 edits. You actually can. So word can become wood. That's 1. Note can become joke because you can change the NT to JK. Ants can not become any, and wood can become wood because maximum can be just 0 edits. Okay. And so the return array is word note wood in that order. Let me think. So I think I understand this thing pretty simply, right? Now the question is, how would you quickly identify whether or not a word can within 2 edits become another word? Within up to 2 edits. Seems like it'd be maybe n squared here. Although this thing only 100 words, each word has length. No, the words are length 100, and there's up to 100 words. So n squared is probably actually faster than what you would expect here because you, given these constraints, it'd be like 1,000 or so if it was n squared. 1,000 length words, 1,000. So maybe this might be n cubed or some other slower time growth. Okay. Word to wood. How would I consider whether or not these two are doable in 1 or 2 edits? Guess you compare the letters in the word, letters in the starting word, and then you see how many matches it has, how many letters match in the same spot and the other in the dictionary. Interesting. That would be a pretty slow comparison because then you have to go letter by letter for every word in the dictionary as a reference point, tracking it. I mean, you could break as soon as you see that it has more than three or more at the third discrepancy. So maybe it wouldn't be that slow. Then you still have to do it for every other word in the dictionary. Is there any benefit to sorting, perhaps? Sorting the dictionary. Maybe. Sorting dictionary. Word to wood. Note to joke. No note joke. N becomes J. O matches. T becomes K. E matches. I wonder. I wonder if I can make some sort of graph from the graph of the words in the dictionary. Like some sort of graph of one letter leads to the next letter. No idea what I'm really considering right now. Huh. Alright, I'm just going to try the brute force method and see how slow it is. So it's just the comparison of every word to every comparison word in the dictionary. There has to be better optimization for this, but so the answer is this. For every query word in queries, trying to list all words that match the same word from dictionary after maximum 2. That's good. So let's see, found is equal to false, maybe should be true. For every dictionary word in dictionary, I'll just make a helper function here. Define, let's say, diff, taking in 2 words. Let's say source, which is a string, and destination, which is a string. And this returns Boolean. And this is going to be returns true if source can become dest within 2 edits. Okay. So here it's going to be for every index. I guess I should probably define n here. Length of queries of 0. So for every index k in range n, let's go diff count is 0. If the source at k doesn't equal the destination at k, so the letter at those indices, then the difference count increments. If the diff count is equal to 3, then just return false. And then otherwise return true if you cannot do that within the loop. And then for every dictionary word I need to compare. So if the difference between the query word and the dictionary word is true, returns true source. If I guess this shouldn't be called diff, huh? say editable. If it's editable to go from query word to dictionary word within 2 edits, then found equals true and break. Otherwise, they'll keep on going to the next dictionary word. And then here, if found being a way for going from query word to dictionary to some dictionary word, then answer appends this query word to the list of words that it works for. Return answer. Okay, I think this should be pretty. This is just the most simple brute force method. I think it should time out if this is. Timeout would be extremely slow compared to what the solution should be. Really? What is going on? That was the solution. Well, I mean, my solution is 10 milliseconds, fastest is 3 milliseconds, so that is a difference of a sizable difference. I want to say this is really unoptimized though. There should be something faster. Like this is just like whatever. There's absolutely no optimizations. I mean I do break early if like there's a detected target that works, or I break early if there's a detected third difference that makes the edit impossible. But besides that, it's pretty. There's no real thing here. So is there a real thing that I can improve this for, like optimization? Like sorting it somehow? I mean, I also think that it's not even part 1 or part 2, so there's no hard version of this. Like I feel like sorting it should in my first instinct is to sort, but then the edit could be on the first letter, so really sorting it doesn't provide much, I guess. Like note to joke, it really doesn't sort very well to help make that match. Right. I have ideas regarding. You have 2 words that are like maybe 1 apart letter, like ants, and maybe ints, ANTS and INTS. There should be a way to use modulo arithmetic to identify that they're somehow 1 apart, I want to say. But I also this is also 2 edits instead of 1 edit, and then I'm actually not fully sure what the strategy is there. Like you do some sort of rolling, no. Hmm. Hmm. I wonder. No, that's like. Wonder if there's a way to make us some sort of hash map. There's too many hashes. Ants. A-N-T-S. So some sort of way to make to hash that into. You'd have to hash into maybe 4 different versions. Now, if you choose 2 letters out of the 4, choose 2 is 6, right? So there'd be like 6 different hashes of stuff that you'd get if you just remove 2 letters from it. And then you'd have to do that 6 hash on every other input query. Actually. All right. I'm just gonna go with this. Although I feel pretty bad about this answer in terms of it's very whatever. All right, summary. I want to say not much to say about the solution I had. Simply, I consider it pretty equivalent to the most direct kind of brute force implementation of comparisons between queries and dictionary. No real optimizations within that. So in overall, iterate over every. Okay, so use a nested for loop. Outer loop iterates over every query word, which I said it was keyword. Inner loop will compare the current query word to every dictionary word. I'll call that D word. Created a help function to verify if the keyword can be converted to the dictionary word within 2 edits. So basically would need to have less than 3 differences in letters at corresponding indices, and then use appropriate logic appropriate logic to determine when to break early and append the keyword to the answer array if there is a possible target in the dictionary that works. Okay, that's pretty straightforward, right? So you iterate over your queries. You assume that it's not possible to find something that works, and then for every dictionary word, you see if it's edible to change the query word to the dictionary word using this helper function. Helper function relies on just the count of the differences, and if the count of the differences is 3, the third difference means that it's not edible, otherwise it reaches the end and it is edible. And if it's found, that breaks the loop, otherwise the loop keeps on going until it reaches the end of the dictionary. If there is a found, then appends. I wonder, in theory, this could somehow be within, like in theory, this, when it breaks here, it wants to actually break to the next iteration of the query because it wants to append right here. Actually, maybe this should be right here. If found, then I'm not sure why I didn't do this here. Answer appends the keyword break. Actually, I guess this doesn't need this found, huh? I guess that's just better. This still needs the break though. Yeah, that's just better. Okay, I mean, I guess this might be slightly faster or randomly slower. It should in theory be faster. Okay, it's like 1 second faster, or 1 millisecond faster. Time complexity is going to be O of, so it's O of n to the third, I want to say. Actually, let me think about this. I think it's O of n to the third. Yeah. So I'll say it's O of n squared times, let's say, k, where n is the length of the arrays and k is the length of the words. Man, my shit is laggy right now. This is in practice here, this O of n to the third, because the length of the thing is the same as the length of the queries, length of the arrays. This is because the loops will iterate over all elements of the array in theory, or in worst case, which would be n squared. Well, the outer loop will go over n, the inner loop over n, and the comparison between words to check if it's edible is O of k, where k is the length of the word. So in theory, if this was a smaller thing, then it'd be kind of, well, the comparison is not constant time, right? The comparison is O of length time, so it's, yeah, O of n squared times that length. It's basically just going to be O of 1, since, well, yeah, since no extra space is needed. The answer is an array, and you have to take up whatever space is required there.